Okay, so here we have 6-2 substitution. We're going to spend 2 days on this. The first day is working problems like your examples 1, 2, and 3 here in chapter 6, section 2. The second day will be like example 4, which is where you work with systems with infinitely many solutions and no solutions, because those you really have to be able to recognize when that happens. So we'll spend an extra day on that part. That's the vocab, or I'll do the read and got it in a single lesson, but again, you might want to go back and be able to review that. So now substitution is just what it sounds like. And if you're thinking about sports, hey coach, can I sub in? Things like that. Or if you replace one thing with another. Well, they didn't have any cheeseburgers, so I substituted, with turkey burger. Whatever. So. It says a method for solving a system of equations where one equation is solved for a variable, and then that variable is substituted into the other equation, creating a multi-step single variable equation. Sounds like a lot of work, but it's really not a big deal. Go ahead and write that down, and on the next page, I'm going to work an example. Okay, so here we can see that I have 2 equations, right? You could try to graph these and, find the solution, that sort of thing if you wanted to. But instead, what we're going to do is we're going to use substitution. So here's the great thing. The y here is the y here. The x here is the x here. Luckily, this one's already in terms of y. So y is solved, and y is 3x. Now, if y were something more, then we'd still substitute that in. What that means, though, is that everywhere I see a y here, I can substitute this 3x in there. So I'll end up with x plus 3x instead of x plus y. And then I have a single variable equation to solve. So let's do that here. So we'll say that, again, we know that in this second equation, x plus, and again, I'm going to take that y and I'm going to substitute the 3x for it, because up above it says that y is the same as 3x. So x plus 3x equals negative 32. Notice no more y to deal with. So 1x plus 3x is 4x's equals negative 32. Divide the 4, x equals negative 8. Now, the thing is, what we're doing is we're still trying to solve that system. So I know that for both of these, they intersect when x is negative 8. But I don't know where they intersect for y. So the great thing is with that, I can take my negative 8 and plug that into either one and find out what the find out the y coordinate is. That's what I'm trying to spit out. There we go. So let's do that real quick here. So, and I'm going to plug it into both just to prove it to you. So right here, x is negative 8. So I'm going to say y equals 3 times negative 8. So y equals negative 24. So what I'm saying is that when x is negative 8, y is negative 24. So that means that my point of intersection is negative 8, negative 24. Now again, I said I was going to prove it to you that it's going to give me the same answer in both. So I'm going to take this one. Let me get this out of the way here. Take this one, and that's kind of funny that moved with it. And I'm going to plug that negative 8 in here. So I'm going to have negative 8 plus y equals negative 32. Obviously, add the 8, and look at this. Y is again negative 24. So no matter which one I plugged it into, I found that the point negative 8, negative 24 works for both, which means that's where these two lines, if I were to graph them, would intersect. Okay, so you've got a few examples, 4 I do believe. The first 3 are related to the first day's homework. The fourth one is related to the second day's homework.